Hey, Algebra 2. Today we are learning a new lesson dealing with kind of what we have the last couple classes, all about radicals and square roots and cube roots, and we're going to learn another way to write those today. So take a look at this meme. It'll make a little more sense in a second here, but Drake's going to help you learn some math today. All right, so I said about multiple ways to write stuff. We can write, let me find it, the square root of 100 equals 10. We can also write that as 100 to the 1/2 power equals 10. Okay, so two ways to write that same thing. Similarly, the cube root of 8 is 2, or 8 to the 1/3 power is also 2. So we're going to learn today to go from radical form, something with a radical, to rational exponent form, writing it with a exponent that is rational, a ratio or a fraction. All right, here's how we're going to do that. Let me tell you a little story first. When I went to Hawaii, probably about 10 years ago, I went to a luau because I wanted to eat some good food and see how the Hawaiian culture is. So we were about to eat, and the Hawaiian that was leading the luau said, "Hey, everyone eats the pig in the ground, the pork, but here's the thing. You got to try this thing called poi. We live off of it. It's a ground up root. It's purple. It tastes horrible, but you have to try it because we like it." So that's what it looks like. Guess what? I tried it. It was horrible. It tasted like toothpaste. It wasn't good. But one good thing out of that, it helps me remember how to convert between forms here. So you just have to remember poi because that just it means power over index. So if you remember poi and power over index, you can't go wrong with this, okay? All right, so if we have the square root of x to the 5th power, that's in radical form. To write that with the rational exponent, my power is 5 and my index is 2. So I can just write that as x to the 5/2, okay? Power over index, okay? The way I kind of do it is I bring that 2 kind of underneath here, okay? But again, poi, power is whatever power it's raised to. Index is always the number, square root, cube root, etc. Okay. All right, using poi, we're going to convert. So write each expression in radical form. Here's how we're going to do that. Power over index, so that 2 is going to come around and become my index. So I have an index of 2, and then I have 6 to the 5th power. Now, there's two ways we can write this. We can write it with the 5 outside, kind of like this, or we can write it as 6 to the 5th inside. I'll show you later where we get to choose which one we want to use, okay? All right, 2 to the 1/3 power over index. That index is going to swing around and become the cube root of 2 to the 1st, or just 2. All right, 6 to the 1/2 power. That 2 is going to become your index, so it swings around, and I have a square root of 6, okay? You should remember pretty soon, 1/2 power is the same thing as the square root, okay? So if you see the any number to the 1/2 power, that just means square root. All right, next one, we have 5x to the 3/4. Now, those parentheses, those are important because it groups everything together. So everything is going to go inside of the radical. Everything's raised to the 3/4, so that 4 is going to swing around and become my index. And then I have 5x all raised to the 3rd power, okay? If you did leave the 3 inside on this one, you would have to put the 5 and the x together. Parentheses are just important because it groups everything together for us, okay? All right, next one here, 4x to the 3/5. Just the x is raised to the 3/5 here. So the 4, when you swing this 5 around, it's going to actually not include the 4. So I have the 4 separate, and then I have 5 as an index, x to the 3rd power. All right, so again, keep in mind what's being raised to a certain power. That's going to help you out. All right, now we're going the other way. We're going to write these, they're in radical form with an exponent, okay? So I have the square root of 5 to the 3rd power. Again, if it doesn't have an index, it just means there's a 2. So go ahead and write it. Now these are going to be easier. Power over index, we're going to swing that 2 back around. So this is just going to become 5 to the 3/2 power. All right, underneath it, that 3 is going to swing as my index, power over index, we get 10 to the 5/3. On the right-hand side here, swing that 5 around, power over index, 2 to the 7/5. Square root of 3, and remember, anything square root is just 1/2 power. That's because my index is 2, it's kind of hidden, and my power is the first power, that's kind of hidden as well. All right, square root of 7n to the 5th. That 2 is going to swing around, and I'm going to have 7n to the 5/2. But wait a minute, that 7n was both inside the radical, so I need to make sure that both of those are raised to the 5/2 power by grouping those together with the parentheses. All right, now that we know the different forms, this might make a little more sense. But the Vans logo is kind of like a radical. What if they just wrote their logo as ands to the 1/2 power? Same thing, right? Okay, so converting between forms is important because sometimes it's better to have an exponent. Like, let's say if we have like 5 to the 3/2 times 5 to the 4/2, we want to be able to combine bases using those properties of exponents. But if we want to maybe evaluate, maybe it's easier in radical form. So there's different ways that we prefer depending what we're doing. All right, and here's those different forms. We have evaluate 25 to the 3/2 power. Now, do you know what 25 to the 3/2 power is? I don't even really know that. This is where if we convert, it might help us out, okay? So we're going to convert power over index. So my index is 2. This is just going to become the square root of 25 to the 3rd power. All right, now remember I told you can write it both ways. You can either write it with the 3 inside or the square root of 25 raised to the 3rd power outside. We get to decide which way we want to do this, okay? Do we want to take the square root first and then take our answer and cube it? I'm sorry, that would be more like this one over here. Do we want to take the square root first and then cube it? Or do we want to raise 25 to the 3rd power and then find the square root of it? All right, I don't want to go 25 to the 3rd power. I'm going to get big numbers. So let's choose this way where I'm going to take the square root of 25, and then whatever I get, I'm going to raise to the 3rd power. Square root of 25 is just 5 to the 3rd. So 5 times 5 times 5 is 125. So you can see it's a little easier to evaluate when we have it in radical form. All right, next one in the middle here, negative 16 to the 3/4. What's being raised to the 3/4? Just the 16, believe it or not. Otherwise, there would be a parentheses with that negative grouping it together. So when we swing this power over index around, that was ugly. There we go. I have the negative sign still outside. That negative isn't part of what's being raised, okay? So I have negative times the 4th root of 16 to the 3rd power. Again, we get to choose which way we want to do this. Do we want to raise 16 to the 3rd power and get a really big number and then take the 4th root? No, we want to take the 4th root right now. Now, this is what we did last class. How do we find the 4th root of 16? Well, I'm looking for groups of 4 when I break this down. So 4 and 4, 2, 2, 2, 2. Okay, there's a group of 4. So I have the negative sign. My group of 4 comes outside as just a 2, and then I'm raising that to the 3rd power. Same thing here. It's not negative 2 to the 3rd. It's negative times 2 to the 3rd. So 2 times 2 times 2 is 8, and then we add that negative sign last. Otherwise, there would be parentheses. Okay. All right, they get a little harder. Let's keep going. All right, evaluate here. And this would be also without a calculator. That's the cool part about everything we're learning here is that we can figure this out without a calculator, okay? All right, negative exponent, don't make me stand on my head. Flip it upside down, okay? So we're going to flip this whole fraction upside down and make that a positive exponent. So we have 27 over 125 raised to the positive 2/3 power. All right, now I'm going to kind of distribute this to each term and give it each its own power. So I have 27 to the 2/3 over 125 to the 2/3. Okay, now we can just evaluate each of these. Now, I don't know what 27 to the 2/3 is, so I'm going to convert to radical form. And I'm going to bring power over index, swing that 3 around. I have the cube root of 27 squared over the cube root of 125 squared. Now, we have to just kind of get good at recognizing cube roots. You can always break these down. 27 is really just 9 times 3, which is 3 times 3 times 3. Okay, so really the cube root of 27 is 3. So I would have 3 squared. And then 125 is also a perfect cube. That's just going to be 5 times 25, and then 5 times 5. So it's actually the cube root of 125 is 5. 5 squared. So my answer is just going to be 9 over 25. Okay. So you'll start to recognize perfect cubes, perfect squares, stuff like that. Again, we can always break it down to find those groups of 3. But you can also think 27, the cube root of 27. Well, 2 times 2 times 2 is 8. 3 times 3 times 3, 27. Okay. So you'll start to recognize those a little more. All right, we're jumping in a time machine here back to 4th grade. Okay, we're adding and multiplying fractions because it's going to come in handy. All right, when we add fractions, what do we need? That's right, folks, an LCD. Okay, we're going back to that. So we can't just add 1/2 and 4/6. We need to rewrite these with the same denominator. So I'm going to rewrite this 1/2 as something over 6. To do that, you see how I have to multiply by 3 on the bottom. So I'm also going to multiply by 3 on the top, and I'm going to rewrite this as 3 over 6. So 3 over 6 plus 4 over 6. We keep that denominator, add the tops, we end up with 7 over 6, okay? Don't forget that LCD. All right, when we multiply fractions, this is a lot easier. No LCD needed. We just go straight across the top, straight across the bottom. We end up with 4 over 12, and then we can reduce that also because 4 goes into 12 3 times, so we get 1/3. All right, that's the difference between addition and subtraction. That is going to come in handy once we start doing that in 1 second here. All right, this one we are simplifying, okay? Simplify rational expression, okay? So we want all the same bases combined together. Now, again, with these problems, there's multiple ways to do it, but just bear with me. We're going to go my way and do it step by step. On the bottom, everything is being raised to the 3/2, so I'm going to distribute that, okay? So let me just rewrite it. We have 5 to the negative 1/2 times 5x to the 5/2 all over 5 to the 3/2 x to the 3/2. All right, next thing we're going to do, I have a negative exponent on top. I'm going to move that to the bottom. So this 5 to the negative 1/2 moves to the bottom and becomes 5 to the positive 1/2. All right, so let me just get rid of that there. All right, what else do we want to do? We can combine the 5s on the bottom. All right, again, when you are multiplying the same base, we keep the base and we add the exponents. So this just becomes 5 to the 4/2, which is just 5 squared, okay, times x to the 3/2. All right, now we just have 5 to the 1st on top, 5 squared on the bottom, x to the 5/2 on top, x to the 3/2 on the bottom. You might remember when we have the same bases on top and the bottom, we keep the base, subtract the exponent, okay? So 5 to the 1 minus 2 times x to the 5/2 minus 3/2, okay? Dividing the base, subtract the exponents. So now we just have 5 to the negative 1 times x to the 2/2, which is just 1. Okay. Negative exponent here, the last step. We're going to keep that x up top, but that 5 to the negative 1, hey, you got to go to the bottom, mister, as just 5. So there's my answer. We had a couple ways we could have done that. At this step here in the pink, 5 to the 1st on top, 5 squared on the bottom. You could recognize that we just have one more 5 on the bottom. You can definitely do that, but it's also good to know that when we're dividing same bases, we subtract the exponents. Okay. All right, one more to take a look at here. All right, let's end with a good one. We have a couple ways we can do this. We have been kind of distributing a power. Okay, so let's go ahead and do that. Third power is just really 3 over 1. Okay, so when we have x to the 1/2 raised again to the 3 over 1, remember if we're power to a power, we multiply those exponents. So really we're going to have x to the 1/2 times 3. And on the bottom, we're going to have x to the 5/2 times 3. All right, so on top we have x to the 3/2. On the bottom we have x to the 15/2. And now we keep the base and we subtract the exponents. So we have 3 over 2 minus 15 over 2, which is 3 minus 15, negative 12 over 2, which is x to the negative 6. And again, when we get that negative exponent, we just have to put that as 1 over x to the 6th power. All right, I lied. We're going to do one more because we didn't even get to use common denominators or anything, and I don't want to deprive you of that. So we got a lot of z's here, same bases, a lot of exponents. We're going to combine these into just one z, okay? All right, I have everything raised to the 1/5, so I can distribute that, but what I'm actually going to do first is combine all the z's inside, okay? Now you remember, if we multiply the bases, we're going to have to add these exponents. And then if we're dividing, we're going to have to subtract. So we're going to need a common denominator between all these. So I want to rewrite 2/3 as something over 6. So I'm going to rewrite that as 4 over 6. And then 1/2 down here, I'm going to rewrite as 3 over 6. Okay, so on top here, I'm going to keep the base of z, and I'm going to add the exponents together as 5/6 plus 4/6. And then on the bottom, I'm going to have z to the 3/6. And then again, all raised to the 1/5. All right, on top, piece by piece, we'll get there. We have z to the 9/6 over z to the 3/6 raised to the 1/5. Okay. Again, inside the parentheses, we have z on top, z on the bottom. When we're dividing the same base, we keep the base, subtract the exponents. So 9/6 minus 3/6. And then again, that's all raised to the 1/5. So I have z to the 6 over 6, which is just 1 to the 1/5. All right, now at this point, we just have to raise z to the 1st to the 1/5. We multiply these, which is just z to the 1/5. So not that bad. It looks scary because it is a little bit scary, but once we get those common denominators, then it's not too bad. All right, let's say you're like, Mr. Miller, I don't want to do that. The first thing I want to do is distribute that 1/5. Okay, let's go and try it that way. Let's just double check we get the same thing. Okay, again, when you are distributing, you're multiplying. So you're multiplying 5/6 times 1/5. You're going to get 5/30. All right, 2/3 times 1/5 is 2/15. Again, multiplication isn't as bad because we don't need a common denominator. And then 1/2 times 1/5 is just z to the 1/10. All right, at this point, you've gotten rid of that whole exponent, but we just need a common denominator to now add and subtract everything. So my LCD is 30, so I'm going to rewrite this as 4 over 30. And I'm going to rewrite 1/10 as 3 over 30. All right, now we're going to do this in one step, actually. Watch. On top, if we're multiplying, we add the exponents. So we have 5/30 plus 4/30. And then we subtract the one on the bottom, okay? Because division turns to subtraction. So we just keep the base, and 5/30 plus 4/30 minus 3/30 is 6/30, which reduces to z to the 1/5. All right, different way to approach it. Same answer. Great job. You're going to come back to class. We have a Go formative classwork that you're going to bust out so that you don't have any homework this weekend. All right, I'll see you back in class. Bye.